Alright guys, welcome to RC Mojo. This week we're working on the Scania 770S, specifically on the coupler. We've got the standard Tamiya setup installed at the moment, which does kind of work. There's just a simple lever to pull forward to open the latch in the fifth wheel. It's all a bit wobbly, and if you don't lift the lever, it catches on one of the screw heads mounting the plate to the chassis. Now, I always thought Tamiya really want you to buy the motorised trailer leg kit and fit the plate with a standard size servo to the chassis, but it's a pretty ugly looking setup. A while ago I designed a replacement that looks a little bit neater and uses a high-tech HS81 mini servo. It still allows the latch to open when attaching a trailer using some model aircraft linkage parts, but we still have the servo arm poking out, so it's not ideal. Enter the new version of the servo mount, which of course is 3D printed. Files for printing your own will be on Thingiverse, and there should be a link in the description. Now, it all fits within the same footprint as the stock Tamiya plate. The lever is free to move, so the coupler can latch a trailer without having to manually open it. And it has a servo that can mechanically override the lever to open the coupler from the radio. There aren't any special linkage parts. In fact, other than a few screws and the servo, everything can be 3D printed. It works by having the servo arm push against a follower that's attached to the lever. The lever and follower are free to move away from the servo arm, but when the servo arm moves, it pushes the follower round, moving the lever. If we power it up on a servo tester, we can see it in action. With the servo in the closed position, the lever freely moves, as we've seen. But if we run the servo, the follower gets pushed and the lever moves to the open position. Moving the servo back, the lever stays put, but when it's all installed on the chassis, the return spring in the coupler would pull the lever back. Right, this one was the prototype, so we need to build one up for this truck. Let's go through the whole process. First, we have the printed parts. We need a plate. Now, this one's been painted, being careful not to paint inside the bearing hole. There's the servo mount, lever, again which has been painted, the follower, a very thin spacer, which it's best to print a couple of these as they do have a tendency to vanish when you're not looking. For non-printed parts, we need two 850 bearings, or 5x8 by 2.5, an M3 by 20 screw, two M2 screws to mount the servo. These ones are a bit short, so something around a M2 by 8 or M2 by 10 will work just fine. 5 M3 by 6 countersunk screws, an SG90 servo, but the Metal Gear MG90 should work too, but I haven't tested one. We need the single straight arm from the servo accessories and the servo arm screw. Lastly, you need the small ball end from the stock Tamiya lever. For tools, other than a couple of Allen keys, you're going to need a 1.5mm and a 3mm drill bit, an M3 tap, and something to press the bearings in, like a vise. A countersunk bit is also quite handy to tidy up the countersunk holes and bevel the edges of a couple of the holes. Now, before we can put the bits together, there's a bit of parts preparation to do. First, we're going to sort out the servo mount. The two holes to actually mount the servo need drilling out with a 1.5mm bit just to clear out the holes. Next, the hole towards the middle on one of the legs needs to be drilled out with a 3mm bit. This acts as a stabilizer for the lever, so an M3 screw needs to be able to turn fairly freely in the hole. We also need to make sure there isn't any plastic swarf around the hole, so a quick spin with a countersunk bit or large drill bit will do the job. If you have an M2 tap, now's the time to use it, or you can just use one of the M2 screws to make a thread in the servo mounting holes. Using a tap is better, but for what we're doing, the self-threading with a screw is going to be good enough. Next, the three holes on the ends of the legs need an M3 thread cutting. These aren't all that strong, so we don't want to try threading a screw straight in. With how stiff it's going to be, there's a fair chance the legs are just going to snap. It was a bit of a compromise just to keep things looking nice and slim. Next, we'll sort out the follower and the lever. Now, the follower has the shaft built in and a key on the top that fits in the hole in the lever to set the angle. We need to press the end of the shaft into the hole so it's fully seated. Do take care though, as until the screw goes in it can be a bit delicate. While still being careful, we need to run the M3 tap in from the follower side all the way in so the end of the tap pokes out the lever side. The idea is we're going to get a thread inside the key and the lever, so when we fit the screw it'll spin straight in. Then we whip the tap out and very carefully separate the follower and the lever. The lever then needs the hole for the ball drilling out to 1.5mm. Then, just like the servo mounting holes, we spin an M2 screw in and take it out to form a thread. Okay, now for the servo. We need to fit the arm in just the right position for this all to work. If you have a servo tester, set it up so the servo is centered, or if you've only got your radio, connect it up to a spare channel and make sure it's centered and the endpoints are equal. Then, with the servo upright and the spline nearest you, start with the arm so it's in line with the servo body, then rotate it anti-clockwise 2 splines. To double check, you can offer the servo up to the underside of the mount, and the last hole in the arm should be in line with the cross brace of the mount. If it's off a little bit, that's okay, just try and get it as close as you can. When the arm's in the right spot, we can install the screw to fit the arm in place. And now for the fun part, the bearings. Both of them need to be pressed into the large hole in the plate. They are extremely tight, and both of them need to be pressed in from the same side. Now flange bearings would be better, but one of the specs I made for this assembly was to try and only use things Tamiya builders might already have. So we used the 850 bearings. To make it easier, you can slightly bevel the top of the hole with a countersunk bit, but don't overdo it. The bearings need to be a good tight fit so they're stable. The trick is to get the bearing perfectly lined up with the hole while between the jaws of a vise. Then carefully squeeze the bearing in until it's flush with the top. Then we line up the second bearing and press that one in too. When done, the bearings should be flush top and bottom, and the swarf from pushing the bearings through should work its way out of the bottom. Clean it up if there's any still attached, and that's all the bits ready to put together. If all the preparations have gone well, this is the easy bit. Right, step 1, the follower. We need to push the shaft of the follower through the bearings from the bottom. Now it might be a bit tight to get it started due to the surface of the 3D printed parts, but once it's started it should pop straight in. Next, step 2, the lever. Now to fit the lever, first we need to slide one of the thin spacers over the shaft. This is so the lever puts pressure only on the inner race of the bearing and doesn't lock the whole thing up. We need to make sure the spacer is all the way over the round part of the shaft past the key. Then the lever goes on and gets attached with the M3x20. For now, we just want to take up the slack in the thread. We'll tighten it up fully when the bottom of the screw is supported in the servo mount. Step 3, the servo mount. All we do is offer it up to the underside of the plate so the holes in the mount line up with the countersunk holes. Then we thread in 3 of the M3x6 countersunk screws. Initially, fit all 3 so they're just taking up the slack, then go round and nip them up properly. And now the screw is properly supported, we can nip up the M3x20 too. That's M3x20 as well, not 22, but you know what I mean. Alright, step 4, the servo. We just need to offer it up under the mount so the splines end up on the same side as the lever shaft, and then we install the 2 M2 screws to attach it. Nip them up and you should have a working coupler release servo plate. I think we're going to need a better name than that, so if you have any thoughts, put them in the comments. Right, to test we can hook up the servo tester again and make sure it's all nice and smooth. If you're testing with a radio, reduce the endpoints before connecting the servo. In the open position, the servo arm can bind. In a future update, I'd like to change the profile of the follower so it doesn't matter how far the servo travels, but for now, just take care with the endpoints. Once it's tested, it's ready to fit to the chassis, although you might want a little tiny smear of ceramic grease on the end of the servo arm, just to keep wear down to a minimum. But that's fully optional, it'll probably be alright just as it is. Right, before we can fit the assembly to the chassis, we need to remove the stock one. First we pop the rod end from the lever, and then we unscrew and remove the small ball end. Don't forget, on the stock arm it has an M2 nut that it threads into, so make sure it doesn't fall out and get lost when the ball end comes away. Next, the two M3x6s can be removed and the stock plate taken away. To fit the new plate, we just offer it up to the chassis and attach it with two M3x6 countersunk screws. Then we thread in the ball end to the lever, doing it up so it's just snug. There's no need to go mad and risk stripping out the plastic. And lastly, we pop the rod end onto the ball. And well, that's it. So if we manually move the lever, it should act like a less wobbly version of the stock setup that doesn't keep catching on the screw head. So even without the servo, it's still a huge improvement. We can test the latch to make sure it's nice and easy to hook up a trailer. I'm just using the shank of a drill bit instead of a trailer pin, but you get the idea. When we hook the trailer up, the latch can open without us having to use the servo. And for the final test, we can hook up the servo tester and open the latch. This time though, the return spring on the fifth wheel pulls the lever back for us. And well, that's it. One remote coupler servo plate jobby installed. Next, we're going to have a bit of a bonus. I think the chassis is looking a bit untidy, so I want to cover it up with some plates. Now, I'm not planning to make these available unless someone really wants me to. They're just a quick design to make things look a bit neater. We've got a gearbox cover, 3 plates and 3 clamping parts. The clamping parts have a step on the ends so they fit snugly between the chassis rails. We offer one up inside the chassis and hold it in place from underneath. The top of the clamp is just below the top of the chassis rails, so when we fit the plate it'll grip and stay put. The idea being that we don't want to drill lots of holes in the top of the chassis. The gearbox cover slides over the gearbox and we use 2 more M3x6 countersunk screws. The only other thing up this end is I still really need to find somewhere for the power switch. Somewhere that's easy to get to, but also preferably out of sight. It's a bit tricky as most of the good spots are just out of range of the length of the cable, and I don't really want to cut and extend it. We will work something out eventually though. The middle and rear plates fit with their clamps and we end up with a much tidier looking chassis. Despite the minimal mounting, they are pretty sturdy, more than strong enough for what they need to do. I think the rear plate still needs a bit of work though. I think the rear edge needs a bit more thickness, but that's a minor thing. Well, and there we go. There's some more of the Scania done, and not just hooking up LEDs for once, although we've still got a fair bit of that to do. So, as always, thanks for watching. Like if you like, subscribe if you haven't, and leave a comment if there's something on your mind. Bye guys!